This is Scott from fairlynerdy.com, and this video shows you how to use a z-table. So a z-table is a table of the normal curve, so a normal bell curve, and it's used for determining how unlikely something is, or how likely or unlikely something is. A typical z-table looks like this, and I'm zoomed in a little bit. So it'll have a z column and then a z row. So this column and this row will be on the outside. And this is the z-value. And the z-value is a measure of how many standard deviations something is different than the mean. And the inside is a probability. And there's a couple different ways this probability can be, so we'll go over those. The z-value itself measures how many standard deviations you are away from the mean. So if your mean for, say, a test score is 50, and the standard deviation is 5, you might be 3 standard deviations away if you have a score of 65. So to find out how likely it is that a average person would get 3 standard deviations away, you could read down the z-value till you get 3. And in which case we go down, we'd see 3, and we'd see that 3.0 has a value of 0.9987, so that's 99.87. And this would mean that 99.87% of people would score less than 3 standard deviations outside of the mean. So there's a couple tricks to reading a z-table. The first one is this. To read a z-table, you have to read down both the column and the row. So if you're given a z-value of 1.05, you'll see that there's not a 1.05 on this column. And the reason is that you have to add the column value and the row value. So here you just go to 1.0 plus 0.05, and you get a value of this. This would be the 1.05. If you wanted something like 1.59, you'd have to go to 1.5 and then 0.09, and you get that value. This is how z-tables are typically presented. There'd be nothing wrong with just making a z-table that said 0.00 has a value. Then go down, 0.01 has a value, 0.02. Make all of these in a single column or a table of columns. But it's just not how they normally presented. This is a somewhat more compact format. So this is the typical z-table. The other thing to know about z-tables is what this probability is. And if it's a cumulative probability, if it's measuring from the left to the right, if it's measuring the area inside or outside the curves. And the way you'll normally see that is based on what is filled under here. So this is a normal z-curve, and my table shows a probability up to a z-value. So it shows a cumulative value until you hit the certain z-value. So how that would look on a normal z-chart is you'd have something that was typically kind of shaded. So your z-curve would be shaded, and you could tell that what was being measured was the values. It's not a great job of shading, but you could tell that what was being measured was the values from negative infinity up until your z-value. So for instance, if I had a z-value of 2, this, the area under the curve from negative infinity until positive 2 is 0.97 or 0.9772. The other things you could see z-values. You could see things that are just the center. So my z-table right here is a one-tailed z-table, cumulative one-tailed. You could see things that are measuring a center area. So if your z-table starts with 0 instead of 0.5, it might mean that instead of 50% of the area being to the left of that z value, it would mean that 0% of the area is contained within a slice that is this wide. That is infinitely small here, but this wide. So kind of the several typical you can see is one would be cumulative until you hit this one tailed, and that happens to be the one I'm using, the one I like. One is two-tailed, so it just shows the area cumulative but two-tailed. One might show the area one might show just the tails, so it would be the area of just the tails, in which case it would be the same as 1 minus this value. Yeah, those are the typical ones you see. So just as an example problem here that I have is for birth weights in a hospital. And here I found that my z-value was 1.46. And so I read from the z-table and I found 1.4, read to 0.06, and see that these birth weights were 93%. That 93% of the birth weights would be lower than this average. And that wasn't enough to get the 95% confidence that I wanted. So that's how you use the z-table. I built this z-table in Excel. I found it more handy to make it in Excel than to go download it off of the internet. You can do that if you use this function Norm.S.Dist and then your z-value in true. So if you wanted to, say, make your own z-table and you didn't want to, use that, make it a square like this, you could use that norm.s.disp, pick your number, true, and these are the same z-values. These are the exact same numbers, but it's kind of read in a column instead of reading across. This can be more useful for things like interpolating. So you can do that in Excel. It's pretty easy. If you want to just download this Excel file, I've uploaded on my website here at fairlynerdy.com/hypothesis testing examples, and that's free. And the other thing I have for hypothesis testing is all the different types of hypothesis tests and kind of the formulas and when you would use them. Just a single PDF file that you can download and print off. And that's at fairlynerdy.com/hypothesis testing cheat sheets. Thank you.